I'm going to explain about depletion mode transistor action. Actually, depletion mode means while fabricating a transistor, while fabrication only, the channel is established between source and drain is called, that is depletion mode transistor. Means there is no extra supply is required to form the channel from source to drain. So it is having three regions. I will explain clearly what are the three regions. The regions are, one is cutoff region, and one more is ohmic region or resistive region, ohmic or resistive region, and one more is saturation regions. Three regions are there for depletion mode transistor action. So as I said, depletion mode means there is no extra supply is required. Already channel is there between source and drain. If you take P substrate or else N substrate to design P, to design polysilicon material, deposit the polysilicon here, and to design source and drain terminal, diffuse the electrons into P substrate. This is N and this is N, electrons into P substrate. Already the channel is established between source and drain. That is called, this is the channel. So of course this is source and this is gate terminal. I will explain clearly the three regions. So these are the three regions I will explain. So one is cutoff and saturation, ohmic region and saturation regions. So for that I will take the first one. You know that what is the transistor fabrication, how to design a fabrication. So you will take one substrate, either P or N substrate you are taking having holes. If it is P substrate having holes, to design gate terminal, deposit the polysilicon material at the middle of the substrate, and of course this is silicon dioxide layer. And to design source and gate terminal, source and drain terminal, this is gate already designed. To design source and drain terminal, diffuse the electrons by hitting this P substrate. We are inserting electrons into, that is P substrate. So this is N, electrons. So but what is saying, it is a depletion mode transistor, that's why already the channel is established between source and drain. Already the channel is there. So in this case, the first condition is VGS greater than or equal VT or less than. So assume that VGS is, that is VGS is 0.2 volts only, 0.2 volts. But we know that the threshold voltage for the transistor, here the threshold voltage for the transistor is, if it is silicon material, 0.6. You can see this 0.2 volts is not sufficient, not satisfied this condition. So that is the reason it will, the current will not flow from source to drain. It will not go to active. It will not react. So in the second case, even if it is VDS, and VDS we are not applying anyhow. So this is the source and this is the gate terminal. This is drain terminal. Voltage between gate and source is VGS. And VDS anyhow we are not applying. So voltage between, that is source and drain. So in this case, the transistor is acted as a cutoff region, because it will not react. Insufficient VGS, insufficient VDS and VGS, both are insufficient. And coming to the second one, second case 2, the same thing. We are taking one substrate, either P or N substrate. If you take P substrate, to design gate terminal, deposit the polysilicon material, that is named as gate. And to design source terminal, diffuse the electrons to design drain terminal diffuse the electrons here. So this is the second case I will explain. Anyhow, the channel is already established between source and drain. So now we can say this. Anyhow, VGS is sufficient and VT means here I am assuming VGS is 1 volt here applied. For example, assume that this is the first condition, and VT we know that 0.6 volts for silicon, threshold voltage for the transistor. So here when VGS is greater, this depletion layer will start to decrease, and start to flow the current from source to drain. So, but the second case, VDS is less than or equal to VGS. So means this is the VDS. VDS should be voltage between drain and source, but it is less than or equal to VGS, voltage between gate and source. So that's why here also the channel is established and there is a channel, and depletion layer is start to decrease, but insufficient VDS. So VGS is sufficient but insufficient VDS. So that's why this region is called as ohmic region or else resistive region. Ohmic or resistive region. It is inactive. The transistor may active maybe, but there is no sufficient VDS, hence current will not flow. And coming to the third case, in this case, so it's the same thing. I am taking one substrate and this is the P substrate. If you want to design a gate terminal, deposit the polysilicon material at the middle of the substrate, and that is named as gate. And to design source terminal, diffuse the electrons, and this is named as source. And to design gate terminal, diffuse the electrons here, and that is named as drain terminal. Here the two conditions, VGS voltage between gate and source is satisfied, for example sufficient, it is 2 volts VGS is there, and threshold voltage for the transistor is 0.6. Condition 1 satisfied, VGS is greater than this V threshold. Of course already the channel is there between source and drain because it is a depletion mode transistor. Already the channel is there between source and drain. And coming to the second case, VDS should be greater than here VGS. So the net voltage is VT. So here voltage between gate and source is VGS, and VDS voltage between drain and source VDS. So now it is greater. VDS is greater than this. Hence the current will start to flow, constantly flowing from source to drain. Condition 1 satisfied, and condition 2, VDS is also sufficient to flow the current from source to drain. Hence the current will flow from source to drain constantly. This is named as, that is, saturation region. So these are the three regions in depletion mode transistor. As I said, if the channel is already established between source and drain, so while fabricating a transistor is called depletion mode transistor, and it is having three regions: cutoff, ohmic, saturation region. Thank you. If you have any doubts, send to me.